Okay, I gotta say, Jackie, you oversold. You really oversold. Not ILF, but me. We're friends, buddies. Yes, I really appreciate them. But introduction, I really do. Um, Hope it's worthwhile. Okay, so I'm really honored to have this opportunity. It's unique. It's super. Now we've spent roughly $1 bazillion trying to find a way to grow crops where water is insufficient, irrigation. We've spent another $1 bazillion roughly trying to drain excess water that has impacted crop production in a negative way. How much have we focused on managing crop resilience between those two extremes? So when I talk about climate resilience, there are basically three pillars that I think it's important that we consider. One of those is productivity. It has to be productive. It has to be stable, and it has to be sustainable. All three of those really are test pillars for climate resilience. Now, the information that you're going to hear, concepts presented in this webinar, many of them are untested, and as such, we are going to prepare a proposal for the USDA this summer, or submit this summer. Now, as part of this effort, our team would really like to get feedback from people that are part of this webinar, especially farmers, regarding your reactions to what you see and what you hear. And how you give those answers to us, we'll give more detail later in the webinar. There'll actually be a link in the chat box that eventually will show up. So this is, when I mentioned resilience, we're talking about Iowa Learning Farm's 20th year, 75,000 paper archive views, Practical Farmers of Iowa, from 1985 until current. These are all critical parts of identifying resilience, things that I think we all know and understand. So I'm gonna challenge you a little bit. Some of you, most of you, have seen this graph before if you've seen my presentations. And what it shows, what's the message that it tells you? On the vertical axis is corn yield, bushels per acre. On the horizontal axis is a horizon depth of topsoil. It's pretty simplistic, right? As topsoil thins, yields go down. Okay, what does erosion cause? It causes topsoil thinning. So me as a soils guy draws the obvious conclusion: soil erosion, land degradation is driving crop yield losses that we see in the state. Most of you will recognize this as a corn yield map or crop yield map, with red areas being lower than average yields, lower than relatively low yields in that field, green yields, high yields. So two questions for you. One is, if you are the ones that have this field and you see this yield pattern this year, will you see the same yield pattern next year and the next year and the next year? My experience indicates there are areas of fields that year after year after year will be higher producing than others. And then the question relative to resilience is, why do we have high production in some areas and not others? A colleague and friend of mine, Bruno Basso at Michigan State University, tried to quantify these relationships. And in that study, he looked at fields like this, but he built patterns in those fields, rectangular patterns. And then year after year, he identified within those fields, and he did studies across the Midwest, are certain areas in the field, are all areas in the field, either relatively high yielding, higher than the field yield average, or are they lower than the field yield average? And then does that relationship, higher or lower, exist year after year after year? So he identified the high yielding areas as high and stable, low yielding areas as low and stable. And then there were sometimes they flip-flop between years. So the outcome of that study is given here. The top numbers here indicate across all states that you see on the horizontal axis of this graph what the average is. 46% of the field areas were high and stable. 26% were low and stable. And then there's 28% that bounced up and down. So the question again to you is, why? We have areas that apparently are climate resilient, the high stable yield areas, at least relative to two pillars, productivity and stability. How they're managed will influence sustainability. We look at Iowa. What do we see? High and stable is about 53, 54%. The unstable area is a little over 30%. Okay, well, interesting. Put that under your cap as we look at the next graphic, because you understand I'm a soils guy. I'm a soil erosion guy. Well, actually, I'm a soil conservation guy, but soil erosion is the other side of that coin. So I'm thinking low and stable yields are caused by land degradation, primarily soil erosion. So we get this study from Evan Thaler, who has addressed the impact, or not impact, but what is the condition of Midwest soils, and particularly targeting the area of fields that are devoid of topsoil. And if you look at the graphic, the text on the left, in the middle of that, it says across the Corn Belt, 35%, plus or minus, pretty variable, of the area is missing topsoil. Totally devoid of topsoil. Okay, well, that pretty much concluded, in my mind, the reason for this graph. You know, in these fields, this graph was developed in central Iowa, field yield measurements with topsoil depth measurements made at each point. So each one of those dots on that map are not triangles, but rectangles, indicate a point where yield was measured and topsoil depth was measured. Also, this data came from years in which the rainfall from May through August was below normal. Okay, so, you know, I'm not feeling good about what's happening, but feeling good about what I think I understand why this thing is occurring. Again, I'm still thinking about this Basel study about yield and yield stability, and nothing is conflicting here. So I had a beer one evening with another colleague, a buddy of mine, Satirius Arcantoulos, so we're sitting there at the bar. And he looks at me and he says, Rick, it's about water. Now, I've heard advertisements that say, yeah, good beer takes good water. Not that I'm promoting beer. And I told him that. And he said, no. He says, crop production. It's all about water. I said, what do you mean? He says, we just published a paper. And what you see here is the paper that he gave me that indicates that shallow water tables, groundwater, that which exists pretty much across all of Iowa, is contributing to corn production and soybean production much greater than we previously thought. I said, how much? Well, within this publication that he gave me, there's this graph. Okay, the height of the bar is indicative of the corn production in a given state. The color insert within each one of those bars indicate the fraction of that production that is based on water from water table. This is a modeling study, and you understand all models are wrong. Some are valuable. This one has value, and Sedaris does a really good job. So anyway, I trust these values. they're pretty good. Okay, so yeah, that's kind of important. And then he pointed to the graph on the right. What about 2012? What was 2012 like? Anybody remember? Hot and dry. What happened to the percent of the contribution from groundwater in those years? It's pretty high. So now I'm thinking, there might be another player here. So I did what most somewhat reasonable people would do. I called Bradley Miller. Bradley Miller is another faculty member in our department. He works on soil informatics. I said, Bradley, you've been working on water table depth across Iowa. Yeah, I have. I said, do you have any maps? He says, sure, let me send you a link. And he did. And I pulled this one. He has maps for every month of the year. And I thought July is pollination time for corn and important for soybeans. So I pulled this map for this talk. And what was most important to me is this thing in the left-hand bottom corner, the legend. What are the depths of water that he's saying exists, depth of the water table across the state? Now, understand 200 centimeters is a little over 6 feet. So then I asked myself, I said, self, how deep do corn and soybean roots grow? Could they be accessing this water, at least in some places in the field? So I thought, well, maybe these numbers, that's just one estimate. So I contacted Soterius again, and I said, what are you using? He said, well, we've done the work modeling what water table depths are. And he said, this is a map showing our illustration of what we think are pretty certain water table depths are. And they've tested their model against the measured values. And what are these depths? Well, the greatest, 3 meters, is about 9 feet. But much of the state has water tables less than that. And what is the corn rooting depth and soybean rooting depth? We're looking at 4, 5, 6 feet. Could they access this water? Well, it's seeming like they could. I've got another buddy, Chris Hay. He's a water management specialist. He reminds me, he says, Rick, he says, irrigated land is less than 20% of the harvested land in the U.S. Irrigated land is less than 20% of the harvested land in the U.S., yet it accounts for 54% of the value of U.S. crops. Water. I'm beginning to believe it's about water. Those same numbers. Critically important. So I started asking myself, I said, how much do you know about water tables? And I haven't studied water tables. It hasn't been in my vernacular. So I did a little bit of snooping around and studying and looking for graphics. And I found this. And this depicts pretty much what I've learned. And the top 2 major bullets, those square ones, are what's most important for what we're discussing in terms of resilience. Water table's not flat. I knew that. The water table is a subdued replica of the topography of the land surface. In other words, that means where the elevation of the land goes up, where there's a hill in your field, the water table itself goes up, but it doesn't go up as fast as does the soil as you move up slope. And in the lower positions, the elevation of the water table is lower, but it's really pretty close, relatively close to the soil surface. So in other words, as we go uphill, the separation distance between the water table, a potential supplemental source of water for our crops, the distance increases. Well, I wanted to see some pictures. I'm a picture guy, so I dug around and I pulled out some pictures showing soil erosion, and then I started asking myself questions. Now, the first one was, where on this landscape are we seeing soil erosion occurring? Well, it's pretty obvious, that light-colored area. And then I asked myself, what is the potential separation distance of the water table as we go uphill compared to the water table likely in the foreground in this picture? It's probably different and probably greater in the distance where that eroded area is than in the foreground. So if the separation distance is sufficient that those crops are not getting water from the water table as a supplemental source, I mean, that's just life. What is the water source? It's precipitation. Yeah, okay, so we have good rain in Iowa. And I look at that surface, and most of us understand that the subsoil is not really very healthy, or at least not what we would consider a healthy soil when it comes to capacity to infiltrate water, or even store water. So now we have a soil there, in my mind, and I haven't gone to this site and looked at, took pictures, that's not very good condition for infiltration. It's potentially separated from a water table that crops can access, at least in the front part of this picture. So I'm beginning to think that, Cruse has not been interpreting these infield measurements of soil erosion impact totally correctly. There may be a water availability being confounded with soil degradation. So I asked another buddy of mine who's working on the Daily Erosion Project, Eduardo Luca, and I said, can you send me a picture of a field that's got some relief, topographic relief, and then give me your best estimate based on the Daily Erosion Project, what runoff rates are across that field. Maybe they're uniform. They shouldn't be, but maybe. So he pulled up a map from the headwaters of, I think it's Tipton Creek, which I don't know where it is, but I can see there's some relief on it based on the aerial image. And he sent me the image of the same field that showed slopes. The brighter the color, the steeper the slope. The greener the color, the shallower the slope. I can see that there is slope differential, which is aligned with the picture we just saw. So I said, Eduardo, what's the runoff for this field? So he sent this. Okay, this is runoff in terms of millimeters per year, the amount per year. The darker the color, the greater the runoff. The lighter the color, the less the runoff. And I'm not the sharpest tack in the box, but I do understand less runoff means more infiltration. And more infiltration means better potential, at least in dry years, like we've been experienced, for better crop yields. Okay, so I look at that ridge that you see running from the upper left to the lower right, and I see on the side slopes elevated runoff rates. On the top, well, we still have higher runoff rates than other places, but what happens at the top of a hill? What happens to the slope? Where we see these erosion events occurring on the side slope, what part of the slope does that occur on? On the steepest part. What happens to infiltration as steepness of the ground increases? So we do have some infiltration occurring on the tops of these hills and better soils. They haven't been eroded. Better infiltration than we do on the side slopes. Okay, so now I go back to thinking about this graph. And I ask myself, where would we find 35 to 40 to 50 centimeter inches of topsoil depth? It ain't going to be on the hilltop, and it certainly isn't going to be on the hill slope sides. It's going to be at the bottom of those hills and the foot slopes where soil has been deposited. Okay. In that position, what's the opportunity, the potential opportunity? Remember, this was done in a dry year, across dry years. What's the opportunity for crops to have access to supplemental water for productivity, for production, that doesn't exist in the parts of the field where we basically don't have any topsoil, which are these eroded side slopes? So I'm increasingly thinking and understanding, I'll say understanding and then thinking, that my past interpretation of these yield reductions that are occurring in Iowa, where we have shallow groundwater, that I've attributed almost exclusively to land degradation, is a combination. It's a combo of soil degradation, thinner topsoils, and increased elevation, which makes it more challenging for these crops to access water from the water table that other crops lower on the hill slope or profile can. Okay, so I want to try to summarize some of these points in a graphic that's kind of more idealistic than probably should be. But the points I want to make based on what I think I'm understanding, and understand this is a utopic representation of what I think might be happening, at least in some locations. Soils are not uniform everywhere. We have side slope or side hill seeps in some areas where we have paleosols. But in general, what we've learned in terms of considering this water management between the two extremes of no water where we have irrigation and needing drainage. And the other point I'll make about this, if we have a potential to manage so that we can access that groundwater, we don't have to pay for irrigation pumping like they do out west. Okay, so the points about this. Drainage management is absolutely necessary in Iowa still. It's going to rain again, and rain more than we want at times. Drainage is imperative considering the position of the groundwater type of the shallow groundwater. That's just the nature of the land surface that we're in. Say tile drainage, good tile drainage is going to be necessary in many places. Excuse me. The water table elevation is a muted version of surface topography. Another important part as we consider climate resilience for crop production, the separation distance between the water table and the land surface, or the position where you plant your crop, increases as we go up slope. As we go up slope, different than crops lower on the slope, we entirely rely on precipitation water for crop growth and our crop yields. And the potential for soil degradation in these areas and potential for increased runoff because of slope is increasing as we go up slope. Erosion in the hill slope is a phenomenon conceptually occurs where crops need that water and where soil health has been degraded. It's an area where we need to improve infiltration capacity. Alternative crops. I don't want to say alternative crops. I want to say crops with different root systems might be grown in some of these areas that could access water that's something that like a corn or soybean cannot. Just an opportunity. You know, an ivory tower farmer is a dangerous farmer. So ideas that I have and think about, you know, may not have value. And that's part of the reason we want this interaction with folks that might be able to use this. So if I were going to grow cover crops, where would it be? Okay, first of all, if I were looking at this diagram, where would I expect maximum runoff and erosion to occur? I put the yellow circle in there as a hint. So if I want to increase infiltration, and I'm going to do it through cover cropping, where would it be? In my mind, it would be there. It's great to cover crop everything, but if you're going to target, to me, that I think is where it belongs. I think field studies that have estimating soil erosion impact on yield may be confounded with water availability, something that we simply have not recognized or appreciated in the past, especially in our part of the world. Yeah, I wasn't going to show this, but it shows up here. Okay, let's reflect back on terms of water table depths. In the loess soils, it was greater than 9 feet. In the till-derived soils, that central Iowa and part of northeast Iowa, how deep? 6. In the till-derived soils, it seems we have a greater potential to interact crop with the water table. In the loess-derived soil, I'm guessing less so. So the point I'm making here, we have a plot of corn yield on the vertical axis, thickness of this topsoil on the horizontal axis. How much yield loss do we see in the loess-derived soils associated with topsoil thickness reduction of 18 inches to basically 0? It's about, what, 12, 14 bushels per acre, maybe 16. What is the yield reduction that we see as we move from a deeper topsoil with the till-derived soil to that where there is much less topsoil? It's more than double. Is this a water-related phenomenon? So let me just hit a couple summary high points, and then a couple quotes from another great Chris Hay again. Water management is critical for climate resilience. That includes drainage, infiltration, and a bullet that I don't have on this one, and that is crop and crop management. How many of us manage our water availability based on what we think exists underground with our crops? Corn and beans, basically, we grow what's there. But can we do better? The water table seems to be a critical player in supporting climate resilience. Soil erosion impacts on crop yield reductions may interact with water limitations. And opportunity to manage water deficit areas may offer an undeveloped opportunity that we have in locations like Iowa. And I want to close with this. And these are quotes from Chris Hay. Again, the buddy that does the work with the with water management. He states that irrigation is declining in the traditionally irrigated areas, which we know, because of a combination of physical and legal scarcity of water and economic drivers, moving irrigation water to other uses. Now, he sent this to me last year. It's still valid year, and it was valid years before. As climate change further stresses irrigation and irrigated crop yields in the West, production will need to increase in traditionally rain-fed areas, that's us, to maintain an increased supply to meet a growing demand. And this one here, I'd like to, target feedback if you're willing to give us that feedback. The idea of reimagining the landscape to optimize cropping systems in terms of water availability will be critical for increasing productivity and profitability of U.S. ag while minimizing negative impacts on water supplies. And Jackie, right here is where I had my fishing pictures, but the in the conundrum that this started with, I brought up the wrong PowerPoint. So there's 0 fishing pictures on this one. I apologize. It's really disappointing. But I do want to make this ask of people that are here. In the chat box, if you're willing, if you're interested, give us some feedback, click on the link. It will take you to a short survey, and that's the address for that link. Now, the survey is short. It's simple. It's basically these 3 questions. Would field maps of estimated water table depth be of interest to you? Would understanding potential sources of supplemental water, that's the water table for crop production, impact your crop management decisions? Might you manage the bejeebers out of areas where you think there's a low risk for running out of water, or find ways to capture water that we currently don't? What questions would you like to see addressed in our upcoming research proposal? That's the extent of the questionnaire. Then there's another component that asks if you'd be willing to have a follow-up discussion. We'd have a virtual discussion to get more ideas, because we really want ideas with people that might use this on how to shape the questions that will go into that proposal. We want to get ideas from those wiser than me. And we will plan a follow-up conversation organized around today's webinar topic. If you're interested in this opportunity, please provide your contact information as you complete that survey, understanding we're not going to link your names with any answers. We simply need the contact information as you to arrange the discussions. So I think it's time for me to turn this back over to the organizers. There it is.
That. Bingo.
Yes. Oh man, I disappointed myself more than anybody else. So it's all yours, Jackie or Mitch or whoever goes from here, if you can take control.
Okay, so I think, do you have the slides at the end, Rick? There you go. So here's our commercial part. While I am doing the commercial, please write any questions. We've got a few questions in, but any additional questions in the chat to me, and I will get them to Dr. Cruse. So if you need Certified Crop Advisor Continuing Education Unit, you need to contact Elena. There is her email by 5 p.m. today with your name, the name you entered to watch the webinar, if it's different, and then your number. All right, so the next slide.
Yep.
Also, every webinar, we ask people to do a voluntary demographic survey. This is for Iowa State University Extension and Outreach. If you've already taken the survey, don't do it again. But if you haven't, we'd really appreciate it if you would take this survey. You only need to do it once. And then finally, the last one, next week, we have Lindsay Pease from the University of Minnesota talking about tile drainage, which is kind of a nice segue from what you're talking about. So we welcome everybody to join us to that. So got questions coming in, but before I get to those questions, I'm going to actually see if Dr. Matt Helmers, who is online, wants to unmute and ask you a question since he's usually the host of these things, but he's out at an event. Let's see if Matt wants to take the first question. And he might have already eaten his lunch or something. Okay, Dr. Helmers is not speaking up. So we have a question that talks about the water table and that it is not actually flat across the landscape. And so this person's just wondering, is there a more accurate term for water table that would help us understand how this works? And is there a more accurate term? Do we need a better term than water table?
We probably do, especially as we start considering if we decide to consider how we manage that water for our production purposes. Water table will be defined as the position. If you dig a hole, the easiest way is to dig a hole and see at what depth you see water start seeping into that hole. The depth that you have to dig will depend upon where you are on the landscape. Now, if I was a scientist, I'd talk about water potential, and water potential changes as you go down. But for all practical purposes, that's the position at the top of the water table. A better term, pick a term. It's the top of the saturated zone of water. If you go down deep enough, you get past that area where water starts flowing in that hole. Below that, it's saturated. I don't know if I answered the question, but.
Right. So it seems to me, so as I listen to you, because we know learning farms, 20 years, farmers don't want to talk about water, except if they don't have enough, if there's a drought, or if there's too much. They don't really, when we talk about soil health and water, the most important thing to them is, does the soil have the water holding capacity that it needs in order to grow their crops? But what I'm hearing from you, but there's maybe a belief out there, if we just put enough nutrients on, then we can overcome some of these other issues. And I'm hearing from you, maybe we have been able to do that, but going forward, we may not be able to do that. Water is still the key.
Well, why? In terms of climate resilience, water is the key. See, we can add nutrients. We can add manure. We can supply what's needed. We can adjust pH for crop in terms of feeding that crop. What we can't do is control the water spigot. We can't control rainfall. We can't control what we do in different positions on the landscape. Now, crop breeding has given us much better response to crop yields under drier conditions. But we're still not going to be able to produce the way we want to produce without being able to. It takes water.
And to use and I've got a bunch of questions we'll get, but to use a simplistic analogy is, our humans cannot survive without water, but we can survive without food a lot longer. So food is not water is the key. Okay. So what crop alternatives to corn and soybeans can help adapt to changed climate? So what are some of the things you're excited about?
Well, anything, and I'm looking at roots. And you got to look at the root, then you got to look at whether it's worth anything. Alfalfa, most perennials will have deeper root systems and a greater capacity to capture this water that is at a deeper location, depending upon location in your field. So those are the ones that in my mind are most important. But understand, I think very simplistically, I'm farming behind a desk at Iowa State. We have bioenergy crops and some markets for bioenergy crops that also have deeper rooting systems. See, if now this is not answering the question, but this has often intrigued me since I started thinking about this in this way. If we were to look at the prairie the way it existed before we broke it, and I'm not suggesting we're ever going to grow prairies here as a hobby, it ain't going to happen. But if we were to forget what's above ground and simply look at the plant structure below ground, I'll guarantee you we would find species that have shallower roots in the lower parts of the landscape where that water table is closer. And as we move up those hill slopes, we're going to find the types of crops, not the same thing about the question asked, what will we grow? But we're going to have crops that have survived and been resilient, productive because of their root structure and the capacity to access water. So I'm kind of skirting around the question in terms of what else we would grow. The other thing I think that's important, and I mentioned this multiple times, is doing what's necessary to increase infiltration in those areas where we don't have access to the supplemental water source. Now, cover crops is the one that immediately comes to mind. Reduce tillage. You got to stop erosion.
Okay, so how do you see drainage, irrigation, climate change, weather extremes from a large watershed perspective, like the Des Moines and Raccoon rivers, and how they impact downstream metro areas, i.e., drinking water for 600,000 Iowans? So, in other words, I think you're talking about water quantity, and how does it connect to water quality?
Will you ask the next question? No, they're all interrelated. They're all interrelated. If you infiltrate water, it's not going to run off. So at the watershed level, if you can capture water, the Iowa watershed approach was about storing water on the landscape. The biggest sponge that we have, the biggest reservoir we have in that landscape is the soil itself. Now, on the watershed basis, quality and quantity intersect in a lot of places. One of the examples, I'll go back to 1993 and a couple times since then, we had repeated heavy storms so that sponge, our soils were saturated. And under that condition, you're going to get runoff on subsequent heavy storms. Sometimes we get questions, in fact, it's more than sometimes, about tile drainage. Tile drainage has an impact on flooding. Well, without wading in too deep, if you have a tile that is draining a half an inch of water a day from a field over a 24-hour period, that gives you increased capacity to absorb water in that field the next storm that comes along. So managing the watershed is complex. It's related to what happens downstream. If you have runoff, you're going to have water quality issues. If you are applying more I'll use it as an example, in areas that are drained, tile drained, and not managing that well, it's going to be at lower parts of the watershed. It's going to get there. So again, I haven't answered that question. Not trying to avoid it. It's really complex. It's complicated. The first thing is get the water in the soil. Use the water that's there.
Okay, so a combination of, like, when you think about some of the watershed projects that are focused on water quality, perhaps we need to have a strong component of water management also.
Absolutely.
It isn't just about cleaning it up once it hits the edge into a wetland. It's about, total.
Yeah. Now, see, one thing that's unique about this, Jackie, what I talked about, is basically all quantity. Our water issues in Iowa have totally focused on the past, other than drainage, water quality, not quantity. Now we're trying to find a way, it's been dry, dealing with quantity.
Okay, what's the impact on those on the water table on the upslope? So you say that the water table is deeper, the greater the slope, the deeper the water table, but then you add tile drainage into those areas. And don't say that we're not draining areas that slope, because we are.
Yep. It lowers the water table to the depth of the tile drain.
So maybe we got to start challenging some assumptions about drainage in the state too, and where it really belongs.
I think we can challenge basically all assumptions. I'm not saying they're wrong, but I think understanding that we may want to use some of that water. Now, there's some studies about capture a tile drain water and then reuse. That's one form of resilience. One of the challenges with that is that our landscape in Iowa, the prairie pothole region, the Des Moines lobe, is built for having ponds that are shallow and wide. What happens to evaporation of water on those areas? So anyway, there are multiple ways of managing that, but yes.
Okay, the water holding capacity of soil versus the level at which a water table exists. How do crops respond to that in light of your presentation?
They're mutually exclusive. Typically, soils that have a healthy water holding capacity have good soil structure, good organic matter content, at least in the surface, which means greater infiltration. So if you have greater infiltration, what does that do to the water table? It helps store water in that water table. It helps move water down to that table. If it holds water suitable for crop growth, that's even better, and it will. So healthy soils typically have healthy drainage, have healthy water retention, and healthy crop growth.
And so the water table does fluctuate year to year.
It will, yes.
Okay.
So just briefly, the level of rivers tells you something about the level of the water table in the watershed. The lower the river, the lower the water table.
Okay. Will those deeper rooted crops change the water table depth?
It will.
Because
It will, and that's part of the study that we're proposing is we're going to have to identify what potential impact that might have. Now, see, we've been using water from the water table in these certain areas, so that's been there, but we haven't thought about its impact on water table depth. If we use it more excessively or more than we are right now, it probably will. We need to quantify
it. So, how would climate change and the shift in precipitation patterns affect the water table for crop management? And we already know that, we're getting water at different times of the year.
Mm-hmm.
Historically, we got
The water table is a buffer. It's not a tub that we can fill and empty and fill and empty. It is a buffer against climate change. It's a buffer against climate extremes, especially drought. So if we get drying periods like we've had 4 years, the water table obviously is going to be lower than it would be if we got more rain. If we get the shift in precipitation where we're talking about more rain in the spring and less in the summer and fall, if we're using water from the water table, if we manage a way so that we're capturing more of that water, it will cause a water table elevation reduction. It's going to. You can't take water from a system and not have an impact on it. Will it be enough to have an impact on whether or not we can use that water? We don't know yet. This is something at least I don't know. And we're building that into the proposal. These types of questions are critically important as we try to move this forward.
Okay. Are there types of corn that grow deeper roots?
Good question, and I don't know the answer to that, but I've heard breeders in their conversations saying that is part of their strategy to increase climate resilience.
Okay, so another person actually brings up pasture management and plants and their access to the water table. And I'm not sure you're going to be able to give a great answer on grazing and conventional versus rotational, but I might throw that perhaps this should be a part of the grant, that we don't just look at row crops, we also look at pasture grazing, and are there new approaches that we need to be thinking there too?
Yeah, I really like that idea. I like that question. In my mind, while I'm trying to ponder this question, I see the potential for rooting growth in a rotational system where crops have it, or the pasture species have a chance to rest, to regrow, and reestablish a root system. Why do we say don't cut alfalfa towards the end of the season? Because it damages the root. You feed that surface with what energy is in that root system. So yes, it will impact. And will it be different in a pasture rotational system versus open grazing? I don't know that answer. I can think of reasons why it would be, but I'm not smart enough to answer that question well.
Yeah, and I know, talking to one of our farmer partners who does a lot of rotational grazing and is in one of the most droughty parts of Iowa right now, she was pleasantly surprised to see that some of her alternative crops came up. Mm-hmm. And she has sheep, and sheep require less than cattle does, but so it's all of that. What plants are we putting out there? What are we grazing? What livestock are we using? Somebody said, isn't this all about increasing organic matter in the soil?
Increasing organic matter will certainly help. It's more, the water table is different than organic matter, other than adding organic matter that improves soil structure will increase infiltration. That will improve water storage in that water table. Water table is basically a storage mechanism for us. There's recent research that indicates, depending upon year, that we're getting roughly 20% of the water that falls from the sky infiltrating and ending up in the water table. So organic matter will increase water storage. Typically, it will increase infiltration. Infiltration, in my mind, is the biggest one in terms of filling that profile.
Okay, and somebody just encourages you to include prairies and pastures in your proposal. And then somebody else mentions that rotational grazing will benefit rooting depths and overall health. And obviously, Rick, I'm going to have the ability to influence you a bit more on Friday when I talk to you, but you got to have a social science element to this because Iowans' relationship to water, while whatever you find ergonomically, it still might be a hard sell because, while all this science was true 100 years ago, the stress to which our system is under today makes all this science crucial. We could take it for granted, the water table. We could take for granted having plenty of water in the state of Iowa.
Let me expand just briefly on that. I've had different conversations with different farmers about this. And the extreme, one guy says, if you think I'm going to manage small areas in my farm differently, you're out of your flippin' gourd. Another one says, you mean if I would manage that so that I can capitalize on water and get maximum productivity throughout that landscape? He said, maybe I can compete with a big guy. It's social. It's mental.
Making the right arguments. Yep.
Yeah.
Okay, so couple more questions. You mentioned Chris Hayes' anticipation that production east of the 100th meridian would need to increase to meet the supply demands. What does that mean for Iowa?
That means that assuming the climate stress occurs the way we anticipate it, we can go back to the Arab Spring and what we had in the 2012 area. See, there was actually international concern about food and food supplies. If that happens, if our irrigation areas decline, which they are, which they will, we have the data indicate that some of these aquifers are being emptied. It puts more pressure on productivity in Iowa. How's that pressure come? Somebody come and say, you got to produce more? No, prices increase. What happens to land use as price of corn and soybeans increase? We farm it harder. We take land out of CRP. Some farmers move into the ditches to farm. We get rid of grass waterways. So that to me is the biggest concern. Land degradation, soil degradation is still a big, big no-no. Well, I've been talking about water. I'm a soils guy. And I'm a soils guy because I honestly believe soils is where it's at. So it means increased pressure through prices typically on productive capacity in Iowa.
Okay, this one I'll throw it at you. Maybe you can answer it. Do you have any information about the water demands of proposed CO2 capture and ethanol plants? Is that related to what you're talking about today?
Yeah, okay, I'll give an answer, and it might not be exactly, I don't think it's exact, but one of the concerns we've had, people say that ethanol plants are consuming water that really shouldn't be consumed. Part of the CO2 capture and whatever. And the argument is that the counter argument is that we're only using about 2 gallons or less than 2 gallons of water per every gallon of ethanol that we produce. That's not the issue. The issue is we're producing ethanol because it raises the corn price, which is good for the farmer. But raising a corn price does what to the capacity for a Kansan farmer to irrigate? Irrigate in aquifers, dig deeper to extract water to produce a product which we've already overproduced. And I sound like I'm anti-ethanol. I'm not getting in that camp. But the water use issue is not what occurs in that plant. 75% of all freshwater use in the world is for agriculture, and most all of that is irrigation. Irrigation is an incredibly intense water user. So that's a connection in terms of ethanol and water use. And I think I avoided that CO2 capture deal. Hopefully
you did a good job of that. So I've got about 3 more questions, and I don't know if we're going to have the time to get to them because I do like to mind the clock and we do like to end on time. So The one person has a quick question of how to determine soil erosion on their farm, and is there a way to predict crop yield potential based on soil erosion and water table? And I actually can answer that yes, through modeling, through all that stuff you talked about. And then, so this is just one on the whole water table. Another question: do winds? We didn't talk about wind. Do winds blowing across tilled soils that dry out soils on high spots or unprotected areas also affect the water table?
Very little.
Okay.
The distance between the water table and the surface, unless that water table is right next to the surface. Once soil dries out, why do we dust mulch? Why do they dust mulch in the West? Because once you get a dry layer on the surface, that soil no longer conducts water. It's an insulator.
Yeah. And I would encourage the person who asked that question about soil erosion and predicting crop yield to go ahead and email you, because you might be able to point them in the direction. And then a follow-up question, this will be our last question. So this increase in supply and demand, would that help Iowa go from corn and soybean monoculture to a more diverse production?
Increased supply and demand, I'm not totally sure, but if there's a demand for something, yes, it increases production. That's just the way we work.
Well, then Iowa State needs to start working on demand for some of these alternative crops.
Well, somebody does.
Yeah.
That's a business decision. It really is.
Right.
I mean, we can create reasons, but it's a culture. It's a culture right now that's really struggling to change.
Okay, well, that's it for today. Thank you for everybody who was here. Dr. Cruse, thank you for helping us celebrate our 300th webinar. You did a great job despite our little technical difficulties. You are welcome to come back. You were with us the first year, and you are always welcome to come back when you have ideas you want to share with people.
Thanks, Jackie. You guys are resilient.